application of integrals to economic problems that we're going to discuss is the topic of present value of a cash flow. Okay, we already discussed present value. When do we need present value? Look, present value is something that we use in a situation when we are supposed to receive some amount of money in the future. And we know that we prefer to have $1,000 today than $1,000 year from now. Why? Because within this year, we can, if we're going to get $1,000 today, we can put the money into a bank and get an interest on this amount of money. And of course, because of that, if we are not getting the money right now, but instead we are getting the money in the future, we are losing this interest. So consequently, the amount of money we are getting later should be worth less to us than the amount of money we are receiving today. This is the opportunity cost that we always introduce into our considerations. And we will also learn how to calculate this present value. On one hand, in continuous time, present value can be calculated as some amount of money we are receiving in the future times the discounting factor that takes into consideration the opportunity cost, right? And this discounting factor is e to the power negative RT. Then, in the discrete time, present value is also some amount of money we are supposed to get in the future, but discounted with the expression like this. Okay, so now let's complicate the situation slightly. What if now you were promised to receive 3 revenue streams or 3 payments, so 3 payments in the value of R. So these R denotes our revenue stream. So we will be getting some amount of money each year. Okay, for now, we're going to concentrate on discrete time, because once we understand how it works in discrete time, we will be able to transform this into continuous time right away. Okay, so we are promised to get 3 revenue streams over 3 consecutive years. Okay, so or maybe time equals to 3, and finally the interest rate we are using for discounting is equal to I. Okay, so what will be the present value of these 3 payments? Well, we can easily calculate it. Look, in the first year, we're going to receive payment R1. In the second year, we're going to receive another revenue payment R2. And in the third year, we're going to receive third payment R3. Right? Now, those payments don't need to be equal. You can get $5,000 first year, $10,000 second year, $7,000 third year. Doesn't work in that. Now, in the first payment, we're receiving within a year. So, how should I discount it? Well, I need to use the discounting factor that we used for and take it to the power -1. Then, what should I do with the second payment? I should also discount it, this time by 1 plus I, but because I'm receiving this 2 years from now, here I will have 2 instead of 1. And then the next payment we are receiving 3 years from now, so we will have 3. Okay, so what do I need to do to get the present value of this entire revenue stream within over these 3 years? We will denote the present value of revenue stream or cash flow by capital letter pi. Okay, so look, what do I need to do is to add present value from the first year to the present value from the second year and to the third value from the third year. And it's as easy as that. As you can see, we haven't actually put here much more knowledge than we already had. We just used what we knew how to find present values and we just added them up. Okay, but of course, writing it like this, very unpleasant, right? Too long. Maybe we can write it simpler using the sum symbol. And of course, look, here we have 3 years, and we will start with the year number 1. In each year, we receive different revenue stream. Then, we discount it by a factor 1 plus I to the power -t. And this gives us the present value of the revenue flow from this example. Now, how can we get general formula for discrete time? Well, actually, there is not much that we need to change over here. Because look, actually, we can still use the same sum symbol. We will always have payments over consecutive years. Then, we need to discount them. The only difference now is that we're going to start from year 1 and we're going to end at year t. Some moment in the future to be defined at occasion we use it. And this formula allows us to calculate revenue stream from any revenue stream in discrete time in the most general terms, and of course put it in the present value terms. Okay, now how I can jump from this to continuous time? Okay, let's start with this expression. Again, look, if I want to calculate this problem similar to this in continuous time, I need to change my assumptions a little bit. How? Well, first of all, this is a continuous payment, but it's not, and because it's continuous payment, it's not going to start at year 1. It's going to start at moment 0. Well, this part will be changed also slightly, but to this we'll go back later. And of course, we need to change the discounting factor from 1 plus I to the power -t to e to the power -rt. Okay, so how should we do it? Look, first we should recognize the fact that we will be also adding payments, but we will be adding all those payments at each and every moment continuously. What do we do in such circumstances? Look, I hope you remember from the mathematics class that we had such a problem. and it was the problem associated with definite integrals, right? We were then adding those pieces, those rectangulars below or below the function, and we were making them smaller and smaller and smaller. As x was getting smaller and smaller and smaller, what was then happening? We were changing the sum symbol into the integral sign. So look, in continuous time, instead of using sum symbol, we will be using integral sign. And as we said before, we will not start at 1, but we will start at 0. Then, here we have payment at year t, but now we need to have a function that gives us exact payment at each and every moment, rt, and then we just finish by adding them from this counting factor and dt at the end. Okay, and look, I hope we can see that right away we can easily change this into general formulation. And general formulation in continuous time would be that the present value of a cash flow or revenue stream is given by integral sign from 0 to some point in the future, capital T, r of t e to the power negative rt dt. Okay, so now we know how to calculate the value of a cash flow, some revenue stream that we are receiving for some period of time. But look, this problem, this formula relates to extremely general problem. But usually the problems we are dealing with are a little bit simpler. Well, and let's consider one of the problems like this. So let's imagine that we've got a situation like this. We will be getting continuous revenue stream of $. So we've got continuous flow or stream flow, revenue flow of $. For Y years and discounted at interest rate R per annum. So per year. Right? Okay. And now, what do we have? What type of situation we've got over here? Look, it's like when you were buying a bond, and this bond promises you to give you, that you will receive exactly the same amount of money each year. That would be like a real life example, or each quarter. But of course, in our continuous time, we're promised to get the same amount of money continuously. Yeah? So, now, what we need to do here is to calculate the present value of instrument or such an asset that is giving you the same amount of nominal money each moment. How do we do it? Look, this can be done, of course, using this formula, but we can easily simplify this formula, right? First, here we start at moment 0 and we finish near y. Now, instead of this function, we can, because we are getting the same amount of money, we can just put d over here, and then we add the discounting factor negative rt dt. Okay, let's try to calculate how much is that. Okay, so first let's get this rid out of this d right away because we don't like it. And 0y, we've got e to the power negative rt dt. I hope at this moment you know extremely well how to deal with such an integration problem when we need to integrate exponential function. What we would like to have over here is negative r, so I need to take 1 over negative r out of the integral. So I'm getting that this is d over negative d over r, and over here I'm having negative r e to the power negative r t dt. Okay, so now I can calculate indefinite integral. Which is e to the power negative rt 0y. Okay, so the next step would be just to substitute the two values, and we will get that this is negative d over r times, first, if I substitute y instead of t, I'm going to get e to the power negative r y, and minus, if I substitute 0 instead of t, I'm going to get 0 here. E to the power of 0 is just 1. Okay. We could use this formula, but it looks very unpleasant. So let me just do one thing and take this minus, put it inside the parentheses, which of course will change the order of these two expressions. So I'm getting that this is d over r, 1 minus e to the power negative ry. Okay, and look, this formula will actually allow us to calculate the present value of this continuous revenue flow, constant revenue flow of $d quite easily. Okay, so let's use an example. Let's start with an example. Let's just say that our constant flow is $3,000. Then interest rate at a bank is 6%, while time period is 2 years. Okay, so let's calculate it. So we've got that the present value of the cash flow in this case is equal to D, which is $3,000 over 0.06, which is 6%. Then we need to multiply this expression by 1 minus e to the power 0.06 times, right, because r, 0.06 times 2 years with minus at front, so to the power negative 0.12. Okay, 3,000 divided by 0.06, it might look complicated, but actually this is really easy once you cancel those two out. We will get that this is $50,000. Then we've got just 1 minus. Well, this one we cannot do without the calculator, but I checked it before. Let me just change one thing. I'm going to change this into approximately because I'm going to be approximating this value, and in approximation this is around 0.89. Okay, now all I need to do is calculate I'm going to get 0.11 out of this, multiplied by 50,000. This will give us $5,500. So look, we can see that in this situation, you are promised to basically get $6,000 over 2 years, right? But once we've taken into consideration the losses associated with foregone interest, this amount of money, this instrument that offers you this type of payment is worth to you, or should be worth to you only $5,500. Well, if you would be offered to purchase this instrument for $5,000, you should definitely do it. But if they would offer you $5,800, this would be a bad idea, because the better idea would be to take this $5,800, put it into a bank, and you would just make more money, right? Okay, now, a very important thing I want to mention at this moment is that this entire derivation from pi, so this expression we all know by heart. It's very important, especially on the exams. Okay, so now let me just show you one more problem that we could encounter. Okay, so imagine that the asset that you got is land, and you can rent this land for $10,000 a year. Now, you know that you will be able to rent this land for this $10,000 a year indefinitely. So, for 1,000 years. Of course, at this moment, unless, we will, as humans, we will figure out how to take our brains into cybernetic bodies. Most likely, it can be rented by your children, grandchildren, 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 and so forth. So this is the type of asset that can bring you a revenue stream for infinite amount of years. Well, yeah, unless, atomic bomb explodes, there is a war, radical change in law, or something like this. But let's assume that our conditions are relatively stable. Now, you are considering to either keep this land or to sell it. For how much should you sell it? Well, in this case, you should probably calculate net present value of the revenue stream you can get from renting this land for basically infinite amount of years. Of course, we need to discount it, because the amount of money you're going to get 2 years from now, 3 years from now, 5 years from now, 6 years from now is worth less and less and less. And definitely, it's nice to know that your grandchildren can get money from renting this land, but it's not going to benefit you that much. So, this is a type of the situation that we call present value of perpetual flow. Now, how can we calculate? Look, actually, we've done most of the calculations over here already. Excuse me. But there's one thing we need to change. And the one thing we need to change here is upper limit of integration. Because now we are not going to be we are not going to be receiving the revenue flow for y years, but for infinite amount of years. Now, you might say that this is very unrealistic. Nobody plans that far ahead. But think about one thing. When the number in the exponent of e is going to be getting bigger and bigger and bigger with minus, this expression with e will be getting smaller and smaller and smaller. So at some point, it's going to be actually so small and so insignificant that actually it's not a big problem. And we use this intuition here. Like if you plan to live 60 years, then using the formula that we're going to be reading right now is good enough. Okay, so let's see what we need to do. Look, again, we assume that we are getting the same amount of money, and we are discounting it the way we always do. Now, what else? So we already calculated, right, that this expression is equal to minus d over r e to the power negative r t. Here we will change this part. T for now, 0 here with some y going to infinity. And look, now we've got to deal with improper integral, so we will have to calculate the limit. But again, it's not going to be that problematic. Okay, let's see. So look, we've got negative d over r, and I'm opening brackets, and first I need to substitute y. But y is going for infinity, so I'm calculating the limit. Limit with y approaching infinity out of e to the power negative ry, and minus e again to the power of 0, because if t is replaced with 0, we get e to the power of 0, which is 1. Okay, I hope I don't need to explain this part much, but I'm going to do it anyway. Look, this expression is the same as 1 over r e to the power ry. Now look, as y is going for infinity, this expression is beginning bigger and bigger and bigger and relatively fast, because this is an exponential function, right? So this entire expression also goes to infinity. And if we divide 1 by infinity, then this expression is clearly going closer and closer to 0. So we see that this limit is equal to 0. So we just got negative d over r times negative 1, which gives us d over r. And this formula allows us to find the value of the land we were talking about. And look, I can tell you actually that once I did an experiment. I took actual prices of rent, I took interest rate, and actual values of flats. It does not hold perfectly, but I was surprised how well it was working. So even though this is very theoretical, it works really well in practice when you consider land, houses, flats, generally the types of assets that can last for a very, very, very long time. Okay, this is the second derivation that everybody knows by heart. If they don't, they will suffer the consequences on the exam. Okay, so not to worry too long, let's just do an example and let's see what we're gonna get. Okay, so now let's just say that you've got a piece of land and you can rent it. Let's just say this is a cheap land, so you can rent it only for $1,450, and interest rate is 5%. Now, what is the present value of a perpetual flow? Oh, sorry, this is F, of course, of a perpetual flow. Well, this is extremely easy to calculate. We just take D over R. How much is it? Well, this is 1,450 over 0.05, which is equal to exactly $29,000. So you clearly see that if you can sell this land for $30,000, it's gonna be a good deal to you. If somebody offers you 25, you should definitely think about it for a little bit longer before you're gonna sell it. Okay, fine. In the next video, we're gonna do our final application of integrals, and we're gonna revisit the problem of wine storage, but this time we're gonna add one thing we couldn't before, which is the cost of storing wine. Okay, see you in the next video.